Chapter 2, Section 4 is all about investigating symmetry. A shape has symmetry if a rigid motion exists that maps the figure onto itself. And that could be rotational symmetry where you turn it, rotate it, or it could be line symmetry where you fold it in half. So our first job is to find the lines of symmetry that would act as a reflection line or a mirror. So it gives you some examples, and here we go through D, and I wanted to show you that D has 2 lines of symmetry and 0 lines of symmetry because this is off center, and then this one has 1 line of symmetry because you can fold it diagonally and this will lie up on top of the other. So take a minute and do the reflection 1, 2, 3 questions just so we can practice. Question 1, the lines are the same length and the angles are the same measure. Number 2 is a circle. Number 3 is yes, because the size and shape is preserved. Next, we're going to look at rotational symmetry, and there is an angle between 0 and 180 that you can turn something and have it land exactly on it, and that something has to be a fractional part of 360. It could be a 5-degree rotation because 5 goes into 360 evenly. It could be a 3-degree rotation. It could be 10 degrees. But it couldn't be 11 degrees because 11 does not go into 360 evenly. Every time you rotate it, it has to fit in every single part exactly. So here is number B, and we're looking at some of the shapes, and it's given us a square, and it tells us it's a square because it's got 4 90-degree angles and all of the sides have the same length. So we can rotate this 90 degrees, 180 degrees, or 270 degrees. This has no rotational symmetry, and this has rotational symmetry if you rotate it 180 degrees, but that's all. So using this information, try reflection 4 and 5. Pause here and come back when you're done. 4 is a circle, and 5 is no. Rotating it will not map it onto itself. And then we have describing symmetries, where we're given the shape and we're asked to either draw the lines of symmetry or name the angles of rotational symmetry, or both. So here, if you have a triangle, and this triangle is a little bit taller than it is wide, whereas this triangle has 3 identical angles and 3 identical sides. So this has line symmetry. You could chop that in half this way if I could draw a straight line. It also has rotational symmetry. You could go across and across and across. You could turn that and have it land exactly on itself 3 times. So 3 divided by the 360 degrees in a circle is 120. So each of these is a 120 degree rotation. This shape has 4 points, and the points have an equal measure, and all of these little lines are exactly the same length. So this has line symmetry here, and line symmetry here, and line symmetry here, and line symmetry here. It also has rotational symmetry. 1, 2, 3, 4 times, and 4 divided by 360 is 90 degrees. So you could have a 90 degree, a 180 degree, and a 270 degree rotation until this came back and landed on exactly itself. Then we want to check out this shape. This shape has line symmetry that way, and line symmetry that way, and line symmetry that way. And it has rotational symmetry 3 times. And we remember here 3 is 120 degrees. So We're going to try your turn, numbers 6 through 9, and elaborate numbers 10 and 11. Pause here and come back when you're done. So here we have this square that's now a diamond, and I have discovered I can't draw diamonds, but I'm pretty good at squares and I don't know what the difference is. So it has all of these lines of symmetry. It also has these angles of rotational symmetry. This shape only has one line of symmetry and no rotational symmetry at all. This one has 5 lines of symmetry. 4, that one, 5. There we go. And it has these rotational points of symmetry because we divided 5 into 360. And we got 72. This one has no line of symmetry and no rotational symmetry. Number 10, both of them will map a figure onto itself. One is a reflection and the other is a rotation. Number 11, you're looking for 2 identical halves, or you're looking for pizza slices that are the same, or however you want to picture what it looks like when you have rotational symmetry. And that's all we have. Our homework tonight is numbers 1 through 16 all. Please let me know if you have any questions, and I'll see you next time.